All right, welcome to our next video on partial fractions. And in this one, we're asked to do a pretty complicated looking integral. It's got 2x squared minus x plus 4 over x cubed plus 4x. And in this problem, we're given this setup, which is often what you'll be given. So we have a template where we know that we can split this up, or maybe it's a hope at this point that we can split it up as a over x plus bx plus c over x squared plus 4. Right, and so let's think about where this might come from. If I factor that denominator on the left factors as x times x squared plus 4. And we can't factor this x squared plus 4 anymore. And so what this book is recommending we do is kind of try and find coefficients a, b, and c that will sort of fit into the system. So in general, like given any sort of possibility for the factors, there's a form and a format for what these decompositions can look like. There are lots of different cases, and we're only going to go through a couple of them in this class. But typically, I will always give you that breakdown. And so I'll tell you what to look for, and then you have to find the coefficients. So let's do that. Let's do the algebra. So here's some algebra. So if we clear denominators, we're going to get 2x squared minus x plus 4 equals a times x squared plus 4 plus bx plus c times x. And if I set this up, I'm going to get ax squared plus 4a plus bx squared plus cx. And now what I'm going to do is I'm going to look at my coefficients. So let's do it in 3 colors. I have a coefficient of x squared, which is appears twice on the right-hand side. I have a coefficient of x, which in this case is minus 1, and that appears once over here. And then maybe in blue, I have my constant term, which appears over here. And so I'm going to look at that, and I'm going to say, well, the coefficient of x of x squared had better be the same on both sides. So I get 2 equals a plus b. For green, I'm going to get negative 1 equals c. That's my coefficient of x. And in blue, that's going to be 4 equals 4 times a. So although this system has 3 unknowns, it's actually not that hard to solve because, for instance, the bottom one says that a equals 1. This middle one says that c equals negative 1. And this last one says that, I guess, a plus b is 2, so that must mean that b is equal to 1. And so at the end of the day, we've found this decomposition. And so if I go and I substitute back in, I'm going to do this with those colors. So b is going to be 1, so I can kind of put this as 1x minus 1. So that's b and c. A is going to be 1 as well. And so now when I put all of this together, I have the integral that I want. So that's the integral of, let me just copy it. So I'm going to have the integral of this fraction is going to be equal to 1 over x plus 1x minus 1 over x squared plus 4. So plus 1x minus 1 over x squared plus 4. I'll put in my integral symbol. And now all of that algebra has paid off because now I can do that. So that's going to be the natural log of the absolute value of x plus this integral of x minus 1 over x squared plus 4 dx. Okay. And that's going to be natural log of x And now I look at this integral, and I could try a couple different things. It actually looks a lot like that challenge problem we saw in an earlier video, where I could actually split it up as a sum of two integrals, so x over x squared plus 4 dx minus the integral of 1 over x squared plus 4 dx. And now I get the natural log of x plus, now I could use a u substitution on this, so maybe we'll do that in green. So now I could use u equals x squared plus 4. Du is going to be 2x dx. And so this integral down here is then going to be the integral of 1 over u, there's an x in the numerator still, dx is going to be du over 2x. I can rewrite this last integral. And then finally, I can evaluate this, so the x's are going to cancel out. So I get the integral of du over u, which is the natural log of u. Rewrite this thing here. And finally, I have this expression, 1/2, I forgot the 1/2, 1/2 natural log of x squared plus 4. And now I have this very last integral. And so I have minus the integral of 1 over x squared plus 4 dx. So the very last integral is looks a lot like arctangent. So it looks a lot like if it were x squared plus 1 in the denominator, then that would be the derivative of arctangent of x. And so this is an integral that we're gonna find it now. I don't think it's exceptionally important that we know how to do it. And I just want to make sure that we realize how much we've accomplished in doing all of this work to kind of break this integral up, and we've found most of the antiderivatives. So we've done so much good work here. So don't be discouraged by this last step. But what we're going to do is I can take that and I can just rewrite it. I can just rewrite this as the integral of, well, let's see. Well, if I wanted to make that something squared plus 1, I could do x squared over 4. I could basically factor a 4 out of this fraction, right? So maybe pause the video for a second here and double check that you believe that this factoring this 4 out is going to be true. If I multiply through by this 4, I would get x squared plus 4. And so let's just focus on this integral. So this is going to be 1/4 the integral. So I'll make this kind of an aside. So we have 1/4 the integral of 1 over, now x squared over 4 is x over 2 squared plus 1. And now I can use a u substitution one more time. This time maybe we'll do it in red. If u is x over 2, du is 1/2 dx. And so if I do this substitution, I'm going to get 1/4 times the integral of 1 over u squared plus 1. And then I need a dx. And my dx is going to be 2, maybe I should solve for it. Dx equals 2 du. So I'm going to get 2 du. And so at the end of the day, I get 1/4, because of the 2 and the 4, integral of 1 over u squared plus 1. And that's going to be 1/2 arctan of u, which is going to be 1/2 arctan of x over 2. And so now let's just put everything back together. Our final answer, we'll do this over here to the left, final answer is going to be log of x plus 1/2 log of x squared plus 4 minus this last integral that we got is going to be 1/2 arctan of x over 2 plus c. Okay. So this video kind of highlights basically all of the methods we've seen except for integration by parts. We used partial fractions, we used substitution, we used an arctan recognition by trying to force our equation to kind of look in a certain way. This is a really challenging problem, and I want to do some challenging problems in this class. So I really appreciate your watching until the end, and yeah, I will see you soon. Bye.